start out, I'm curious, how did you choose your city's urban agricultural design?
We chose shrimp and sea asparagus because they can both be grown together in a system called aquaponics in seawater.
After learning that Puerto Penasco or Rocky Point has freshwater shortages, we chose sea asparagus because it's a halophytic crop, which means it can be grown in salt water. And so we chose that so we didn't have to use any extra fresh water.
We wanted to use canals for our city because at the beginning of the brainstorming process, we wanted canals all throughout our city to make it look beautiful. And we wanted to put the canals to a use, and so we decided we would grow our protein in the canals. But once we realized that shrimp were easily susceptible to diseases, we wanted to put a protective layer over the inner canal where the food is grown.
Thank you. Next question. Why would your city's infrastructure make someone want to live there?
Marseille is a fun place to live. I would like to live in Marseille because it's not only has innovative technologies, it also has fun recreational purposes, such as the Marseille Madness Amusement Park and bike sharing stations throughout the city.
These white sandy beaches in our resort are tourist attractions, so tourists would want to come to our city and visit and enjoy our city.
What innovative and futuristic designs are used in your urban farm environment? And also, could you point them out on your model too?
Inside of the canals, super intensive shrimp farming technology is used to grow these shrimp in minimal water and space. And it uses a closed loop system so that water can be reused efficiently.
A cool thing I learned that I think is really cool that's not exactly demonstrated on our model, but the material science engineers had to create a pH neutral polymer, which would then go and line the base of our canals, because we learned from garden pool that if you have cement or concrete canals, it would leach the alkalinity.
Can you also use the model to demonstrate your moving parts and explain how you made them operable?
In our city, or in our model, we have 3 moving parts. 2 of them are manual. First, we have our computer-controlled quadcopters that assist our emergency responders. We also have an ocean overlook Ferris wheel.
And we also have our CAP system, which is our transportation. There we go. It is motorized.
Can you explain it again about how you actually connect them all?
Yeah. So in the design of our process, we had to prototype it, and we found during our designing that the gears that we were using on it did not connect to the bead chain well, so we redesigned it to use tires now, so it works much better.
Also, in prototyping our model, we set down a piece of paper that has the same model dimensions, and then we laid out what buildings we wanted on it and decided where we wanted to have our urban farming solution and what moving parts we wanted to include.
So, have you thought, I'm wondering a little bit about how long the growing season is in your city. You mentioned a lot about agriculture and shrimp and how you harvest it. How long does it take to produce your crops and harvest your food source?
It's a staggered agricultural cycle, so food is always being produced on demand because it all starts at different times and it can be harvested whenever.
Also, throughout our city, we have 4 seasons buildings, which they can each grow at different seasons through using the monitor technology, and when they can control so that we can have all seasons of fruit and vegetables.
The excess shrimp effluent from our canals is also distributed to all of the other gardens in our city, including the rooftop gardens that we have on multiple buildings.
Which part of the engineering design process was most challenging for your team and why?
I think a challenging part was designing our cap system when the gears would not fit to the chain that we had to use tires instead.
I thought it was really challenging to go on all the field trips and learn about all the technologies you had. Then it was challenging and also fun for me to find a way that you can incorporate all of them into your city.
Could you tell me a little bit more about your education system and the use of holographics for your students?
The educational system is interactive so that it's more fun for students to learn and they grasp more of the information that's set before them.
We also use biometrics to notify if the students are either learning their best or if not, so then we know that if we need to engage them more in one subject or another. And also we have real world applications so that not only doing math, you get to see what math does in the world.
Our system has support for children with learning disabilities also.
Can you explain to me what, you mentioned your photovoltaic system for energy for growing. Can you explain how you power your transport system with pods?
Our transport system is powered by the photovoltaic solar glass that covers the outer dome of the canal, which uses concentrated solar technology to power the pods.
Also, we have hydrokinetic wave technology, which takes your the waves and the vortex of the waves, and it moves a pole up and down vertically, and that puts kinetic energy, so that can also be used to support our city when maybe there's not as much sunlight.
Excellent. Nice job, guys. Thank you very much.